Short on local water supplies and long on regulatory requirements? Do a deep dive with us by listening to the Full Circle podcast to learn how Las Virgenes Municipal Water District and the Triunfo Water Sanitation District are meeting 21st century water supply challenges for a portion of the Los Angeles and Ventura County regions.
Hello, and welcome to the Full Circle podcast, where we are discussing all things water in the Las Virgenes Conejo region, specifically water reuse, and the Pure Water Project Las Virgenes Triunfo set to bring us a new supply of water, locally sourced, starting in 2028. Today is a very auspicious episode, as we are going to be touching on the topic of AI, artificial intelligence, which I think we can safely say is sort of at the forefront of public consciousness. We've been opened up now to ChatGPT and Bard and these different accessible channels of AI that we are now able to incorporate into our everyday lives. There has been some beliefs and thoughts about AI for decades now. There have been movies. I remember watching that movie with Haley Joel Osment, I think, aptly titled AI. And there's all of these, fantastical visions of what it can and what it can't do, and will it, supersede human control and things like that. And so a lot of people have a lot of opinions about it. There's a lot of knowledge. There's a lot of facts out there. I think that there's a lot of science, obviously, some pseudoscience, maybe not. But we are going to actually be discussing today how we at the JPA have been able to incorporate AI into our operations, not just with the Pure Water Project, but with some of our other treatment operations, specifically our wastewater treatment over at Tapia, and how we are looking at being able to use it for optimization and all kinds of other great things that will eventually benefit our customers. So let's get right into it. I'm super excited today to have our guest, our Director of Facilities and Operations, Jean Zhao, PE. Thank you for coming. We're happy to have you, John.
Thank you, Riki, and glad to be here.
Yeah. So can you give us a little bit of background about your journey in the wonderful world of water and kind of what has kept you here for so long?
Thank you, Riki. Being here for 16 years. I started my career right after college as a civil engineer. And
where'd you go to school?
Cal Poly Pomona.
Nice.
And we call that the real Cal Poly because you have to get a part-time job. 80% of students has a part-time job.
The real, does that insinuate that there's a fake Cal Poly somewhere? Are we dissing Cal Slow right now?
Cal Slow, if you go to the Central Coast, they would add it. That's the real Cal Poly.
Oh.
Because more academic than hands-on experience at Cal Poly Pomona.
Oh, I see.
But for the Pomona alumni, we always say, that's the real Cal Poly.
Gotcha. Shout out to Cal Poly. I'm from the IE. I'm from Ranch Cucamonga, so Cal Poly is a local university out there. Shout out to Cal Poly Pomona.
Thank you. I've been in the business for about 32 years. Been with Las Virgenes for 16 years. Love every minute of it.
Nice. I think we can all say the same. We love it here at Las Virgenes and the JPA, including. Yeah. So what kind of draws you into the engineering aspects of water? Can you talk about that a little bit?
Yeah, it's you kind of I picked civil engineering because my dad was a civil engineer.
There you go. That's what I was looking for.
Yeah, and he'll take me to the construction sites, and lo and behold, I figured out. You mean you don't have to stay in the office 100% of the time and still be able to make a living? Right. So that's drawn me into civil engineering.
Okay.
And I started out with county sanitation districts, which they operate water treatment plant and landfills.
Okay.
Did a lot of field work, field monitoring, groundwater quality monitoring. Then I moved to city of Santa Maria, and as you progressive on the promotional ladder, you get more and more responsibility. So lo and behold, you have all the wastewater treatment, water distribution, in addition to other duties as directed.
Yes. As directed.
Yeah.
Unspecified. That's where
Yeah.
they get you, right? So is it safe to say, or what type of engineer was your dad? Was it safe to say that you always had a dream of working in water and being a humble public servant? Public servant?
No, most of us don't have a dream to work in the field. You kind of fall into it. You
Right.
learn how to love it.
Yes.
So my dad was a structure engineer.
Okay.
So he designed skyscrapers. But one thing I remember what he told me is never be a structure engineer because you're laying down in the middle of the night thinking if everything you did is right, if
Oh
the
my
building
gosh.
doesn't hold up.
Right. Or like
So,
a bridge or
yeah.
something. Ugh.
So he thinks it's too much responsibility. So when I was little, I drove into my don't be a structure engineer. So I'm a general practitioner, jack
Okay.
of all trades, master of none.
Oh, there you go. I love that saying so much. But like specifically the second part, I think you always hear like jack of all trades, like they're just great at everything. But that second part, master of none, gives a lot of context. Like you're into a little bit of everything, not just like super focused on one thing, right?
Yeah, use the example of water, right?
Mm-hmm.
You talk about water and AI. To me, that's something people use every day, right?
Mm-hmm.
Ever since you're an infant, you use water.
Mm-hmm.
So everybody has opinion about water. AI, most people don't realize that you use AI the minute you wake up. The minute you sleep, you use AI every day.
Ooh, how so?
So all your appliances has all the algorithm that built in.
Mm.
If you drive a modern car, has so many computer chips in there.
Ooh, that's a good point.
Has so much logic built in. Now the AI right now we discuss, such as ChatGPT,
Mm-hmm.
it is just an interface that enable everybody become a programmer. For example, as long as you can ask a question, you can be a programmer. Because what's behind it is what's in on the chips. But until this point, there's no very easy interface for average people to interact with AI.
And that's sort of like the gate, right? That's kind of
Exactly.
keeping people maybe limited from being able to really realize its full potential.
Yeah, so the good analogy is back in the days, you learn how to use DOS. And you have to be a programmer to understand how to write programs using DOS.
What is DOS?
DOS is a operating system before window,
Ooh.
before you click the icon
Ooh.
and run the program. You have, for example, you have to copy something. You have to physically type in the word copy, what file you're writing, from what drive to what drive. You have to physically provide instruction for the computer to execute.
So there is basically no automation.
Yeah,
Okay.
so it's you have to be a programmer to learn how to use DOS.
Way less accessible.
Exactly.
And certainly not as easy as our iPhones.
With Windows, you all you know is which icon to click, correct?
Right.
You can open up Word, you can open Excel, and you can play games on it. And ChatGPT is more like a window icon. Now, as long as you can ask questions, you can query the data behind AI and provide the answer that you're looking for.
So we're really looking with this new mechanism of AI or mechanisms are just making it more accessible. It's not like we haven't had it this entire time. And I think it's safe to say for the most part we've handled it pretty well. You know what I mean? Like my coffee machine isn't directing my everyday life and like enslaving me, right? Like we've still been fine. But now we're just looking at ways to use it in more advanced ways for better, for more good.
Absolutely, yes. Yeah.
So I think, John, that this might be a moot point right now, but do you have a specific opinion or stance on AI, considering, sort of people's thoughts about it right now and the fears that have been expressed? And I want to ask this outside of the work that you've done with the JPA on AI with, our water systems. Just in your personal life, do you have like an ethos around it or boundaries that you've had to set or anything like that, knowing what you know?
Yeah, for example, I have automation around my house, right? My sprinkler system is automated, right? Like a ratio that the district is promoting, right? I have automatic garage door openers that My camera will recognize who's in the driveway, maybe open the garage door for them,
Right.
right, if it's a family member.
Wow.
So those are
That's
part
really
of the
cool.
AI, right? However, you're not rolling 100%, right? In the back of your head, you always said, what if?
Right.
Right? What if it doesn't work 100% of the time?
Right.
What if?
Yeah.
So a lot of the program and algorithm we call fail-safe built-in, right? And to address the what if scenarios, right? Same with when we treat your water, deliver the water, make sure it meets the health and safety standards for consumption, right? We have what if scenario.
Sure.
Double 3 times.
So contingencies, basically.
Exactly.
Okay.
Yeah.
If something were to go wrong.
So it is okay to question it. It is okay to question more, especially if you don't know, and that's our defense mechanism.
Sure.
Right? So what I recommend to you is look into it, and it will alleviate some of your concern, but question more. And that's how progress is made.
Lead with curiosity.
Absolutely.
I like that. And not suspicion.
Yeah.
So before we move on, just one more thing. Does this mean, John, that you have a contingency for if some AI mechanism in your house goes like full on Skynet? Are you prepared to deal with that?
Yeah, I don't think anybody is ready for that. Right?
Isn't this a possibility?
It is a possibility. It is more of a comfortable level. Understand the backup system. And the more you're comfortable, the more you will let the automation take over. But I don't think we're 100% there.
Sure.
So the 100% is a elusive goal, and you may be 99.99% there, right? So when we treat the new source of water, right, we call the 12 log removal.
Sure.
And 12 log is 90 point additional nines behind the decimal point. 99.9999
Right.
removal, total of 12 nines.
Right. Log removal, for those that are not familiar, we haven't, touched on that yet. It's basically how we measure the effectiveness of filtration and like the cleanliness in water. And so as you mentioned, you said 12 log.
Right.
That's 99.99s, so 99999, however many 9 times, percent removal of constituents or contaminants in the water.
That's correct. So you're not really 100%, but 12 nines is a lot of removal.
Pretty close.
And we're whatever left over, it will not cause you to be sick.
Yes.
It's healthy enough to drink. And that's the healthy standard for the new source of water.
I think I would trust 99.999999, right? We can't earnestly say 100%, but that's like pretty darn close.
Yeah. I wouldn't trust anything with that many nines.
I would too. Okay, so some really common sense advice as far as how to regard AI and trust it. We really appreciate kind of alleviating some of the anxieties that there are, around AI. But now I want to get into how we are able to positively and effectively use AI in some of our treatment processes as it regards to Tapia, right, with wastewater, but also, sort of our current topic, pure water. So let's get into the meat and potatoes, so to say. Can you sort of start off by giving us a high-level overview of how we've demonstrated the effectiveness of AI and machine learning to optimize certain processes in the advanced purification system and at Tapia?
Okay. So before I go into AI and the machine learning, let's just talk about how we run the Tapia water reclamation facility.
Yeah, let's talk about it.
Right? Before AI, before computer, right? We've been in the business in the last 50 years,
Ooh,
50 plus years, right?
Yeah.
I mean, how we run the business, before all the computers, right? So in the wastewater treatment business, we have no control to amount of water flow when they're going to come to us, right?
Right.
Because people wash their, go to the toilet or wash their hands 24/7.
Yeah.
So we literally provide service to the ratepayers at 24 hours a day, 7 days a week, 365 days a year, right? However, we have technologies over the years where we're enabled to staff only work 9 hours a day. right? 7 days a week. So that's a huge progress. When we first started, you literally have to staff 3 shifts because you have to provide that service and meet all the regulatory requirements. Now we've progressed into only 1 shift. So that's a great cost savings and also efficiency.
And part of that is because we've been able to automate those processes.
Exactly.
Correct?
Even without AI, right? We have sensors, we have flow meters, we have computers that
SCADA.
it's called SCADA, right? Supervisory control and a data acquisition, meaning our operator can look up on their computer at home, know the status of the treatment plant and where the bottleneck is, where they need attention, where the alarm is, where the high flow is. So they know all of that. So that enable each of the operators work more efficiently, right? So as a result of that, we only staff, like I said, 9 hours a day, right? 7 days a week instead of 3 shifts, 24/7.
Right.
But we're still providing the service to our residents at a 24/7, 365 days.
Yeah.
So
we got limited staffing resources. You know what I mean? We can't have staff on 100% of the time on site.
Yeah.
But we can still be on or on call, like we like to call it, because of that automation.
Exactly. Yeah. So the computer has enabled us to be more efficient and more reliable. So what we want to do is we want to take that 1 step further, right? So as you imagine, at your home, how many devices you connect to your Wi-Fi? Probably a lot.
Yeah, all of them, all of the devices.
Right? from your, I recently bought a refrigerator. It required me to hook up to my Wi-Fi.
Ooh, that's fancy. Does it have a TV on it?
No, I forgo that. I have a real TV, so I don't need a
you don't need one in
refrigerator
your
TV. Yeah, but everything's connected to the Wi-Fi. So if you imagine your homes like that, industrial facility like a wastewater treatment plant, we have literally tens of thousands of those devices connect to the network, right?
Yeah.
So with all those devices, a human brain is not made to pay attention to all those 10,000 input output every minute of the day. And that's where the AI comes in, right? It takes the data, it sorted out, it only lets you know when certain anomaly occur, need your attention. Now those anomalies may not be just one instant, maybe a trend that you need to look at, right? So the AI able to take those tens, hundreds of thousands of input and output, every day, sorted that out, and also put in the background for you to use when you need it. For example, you want to see how efficient you're operating for the last month. The data's right there, right? So everything we do, and if you ever been to a wastewater treatment plant, it takes a lot of energies.
Yes.
Right?
Yeah.
To pump the water, to provide the air that the wastewater need to grow the bugs that clean the wastewater.
Yeah, let's get into that because there's, this water energy nexus that we try to message here, but that is not commonly known. I think people at this point know that it takes energy to move water around, especially statewide or even regionally. But with our specific processes at Tapia, can you talk about the BNR tanks and the aeration that occurs and that energy use and how AI is improving that and maybe helping us cut costs?
Yeah, exactly. So water industry is the most energy intensive industry in the United States, right?
Wow.
It's the single largest energy user for water industry, right? So here at Tapia, before we add solar, before we start improve efficiency, we had equipment dated back in the 60s and 70s. We call those a blower. It's a gigantic fan, right? And it produces lots of air that we inject into the wastewater to provide the conditions for the wastewater cleaning bugs to live, right?
Our hardest workers, those
Exactly.
microorganisms.
We provide the conditions
Right.
for them to thrive. And when they're thriving, that's how the contaminants in the water gets cleaned, in the wastewater gets cleaned,
Okay.
right? And we clean to a standard that's called EPA Title 22 standards. That means if you're able to swim in it, you're able to gulping it
Right.
without getting you sick.
That's that recycled water that we use for irrigating around our service area. Obviously, also going to be our source water for that pure water project. So those microorganisms, those are, again, some of our hardest workers that help us to kind of break down some of the more harmful gases, ammonia, nitrites or nitrates.
Both.
Both,
Yeah.
nitrites and nitrates, to a more simple nitrogen gas, just, thus cleaning it, so on and so forth. We don't have to get into the super specifics with that, but as you mentioned, we're able to use AI to help the situation with those blowers.
Yeah,
Can you talk about that?
For example, we provide a condition, like I said, for the bug to thrive, right?
Mm-hmm.
You can relate to your home, right? You have in the wintertime you have heating, in the summertime you have air conditioning. Those takes a lot of energy, similar to at the wastewater treatment plant. Pumping water, pumping air in large quantity takes a lot of energy.
Mm-hmm.
So what we have been doing is we are retiring some of the decades-old non-efficient equipment. We're replacing with modern computer-controlled, AI-controlled equipment to be able to run more efficiently.
Right.
Right. So as a result, we almost cut 50% of energy use at Tapia Water Reclamation Facility.
Wow.
We means the operators, operate manually to the best they can based on, tens of hundreds of thousands of dollars input output data, right? So we were thinking maybe we can do better, right? Can we deploy AI to see how much energy we can further reduce?
Right.
So we did that about a year ago, 9 months to a year ago.
Mm-hmm.
We partnered with half a dozen companies. We partnered with a company called IOSite from Israel, which provide a platform to gather data from different manufacturers. I talk about all the sensors, right, from lots of manufacturers. So they have a platform that easily gathers those data, right? We also obtain fundings from Metropolitan Water District of Southern California, provide
through the FSA program, right?
FSA program, yeah, Future Supply Action funding. We also partner with National Water Research Institute. They provide some funding. And then there's a hardware manufacturer such as Yokogawa from Japan, and also the Japanese Ministry of Economy and Technology provides some funding. So what we did is we deploy AI, but not in the sense where the AI has 100% control, right? We put an operator in between the AI and our treatment facility. So any feedback from the AI has to be manually input into our automation system to run the wastewater treatment plant. So the AI takes those hundreds of thousands of data that's generated and get into algorithm, and then output recommend what you should adjust. Then during the test, our operator manually adjusts the processes to be more optimum. So we did that for a week, and the results is that, I think our operator is the best in the industry, but however we are able to squeeze additional 10% energy savings based on the output from AI, and we're also able to improve the water quality by additional 8%.
Wow.
Now, I would rate our operator A before AI, right? They get an A grade,
right?
Because they literally achieved 90% of the most optimum energy usage. However, like I said, human brain is not made to understand hundreds of thousands of input and output a day.
Right, processing that over minutes or hours, it's just not possible.
Exactly.
Unless you have AI.
Unless you have AI. So AI would be able to really get 100% of your energy savings, right? So we were able to get an additional 10% energy savings, reduce energy by additional 10%, while improve the water quality by additional 8%. So that's a great success at a wastewater treatment plant, right? So coming back to our pure water demonstration project, we deployed AI to see if, so first, before I get into it, we'll talk a little bit about how our pure water demonstration project is built, right? It uses membrane technologies, physical barriers to achieve, we call the log removal, right? 12 log virus removal, so it used physical membranes. So getting into this AI experiment, we were thinking, we're going to have a huge amount of input-output data, just like from our SCADA system, the automation system. Let's see if the AI can be a virtual barrier using the data that our physical barrier has processed.
Right.
Can AI be the best operator that we don't have to pay to stand guard to safeguard the water quality?
Right.
Right. So,
but without actually taking away any jobs from our human operators, right? And we can get to that a little bit later, but we're really developing this technology to use in conjunction with our human operators and to help them do their job better.
Absolutely. So the main human, our operators are certified, and they're certified by the state to run the wastewater treatment, to run the water treatment, right? So they have to pass certain tests. So what the AI does is put in the data in front of them, so our operator will make a decision on how to fine-tuning the treatment process. And you not only you save energy, but you have a better product, right? You're able to catch up things much earlier before the alarm sounds.
Right.
Right. So that's what AI is for us, right? So we applied AI for the pure water demonstration project, and what we find out is that for membrane process before AI, it has a very rigid cleaning process. Much like you have a water softener at home, or you have it constantly need to backwash in order for the membrane to continue to process water, right? So using AI, not only we're able to produce the pure water at a much steady state status, but we're also able to use a lot less chemicals to clean the membranes, right? So we all know water quality fluctuates from minute to minute because you have a different contaminants, you have a different pressure, you have a different operating scenarios. What AI does is that rather than going up and down and have a chemical algorithm and chase the up and down curve, AI enable you to operate at a steady state.
Nice. So it wouldn't matter what our flow was at a given time, our flux, right? Flux changes, or the flow of water into the system. That's not something that we can always control, but we can control how we clean it.
Yeah. Also, because the water quality changes, the pure water project equipment, the way they operate, it changes.
Right.
Right? So as you see, all those things changes as an operator, you have to continue to chase, react to those changes.
Right.
What an AI can do is not only look at the history of how this machine operates, it will predict how the machine is going to operate 10 minutes, 15 minutes, 20 minutes, an hour down the road.
Okay.
So with that, enable you to make a decision. Really, you if you can see the future, you are able to make a better decision, right?
Right.
All of us can, right? So it gives you that tools for you to be the best operator you can. So not only it saves energy, it saves chemical, it saves the maintenance on the membrane, so membrane can last longer. And best of all, it produces reliable water that people can rely on, right? It's meet all the health and safety standard from the state and from the US EPA.
And it's allowing us to see into the future. I mean, that's pretty cool, right? Obviously, it's using, trending data points that happen over, a period of our history, but we're able to predict problems before they even come, which obviously lends to greater quality in water, as you mentioned, but just overall more efficient operations. We don't have to wait until the problem is here and react. We can be proactive.
That's absolutely right. Best of all, I call it a virtual barrier. We rely on physical barrier to clean the water, right? But with AI, now we have a virtual barrier to signal us early in advance when we have equipment issues, when we have water quality issues. Again, the AI provide the sensible data to the operator for them to make a better decisions.
Okay. So we kind of touched on this a bit already, but you talked about how we're using AI to not necessarily control what's happening, but to give us data points to allow us to then, make decisions. So we're on this, I guess we call it the semi-autonomous operation track, right? That means that there's all this data that's happening and they're digesting it for us. It gets sent back to the lab in Japan, and then it gets sent back to us, via the cloud, and then we're able to react. What would a fully autonomous operational track look like in this context? And do we ever see ourselves going in that direction?
Yeah, I think in the foreseeable future, there's no, 100% log removal, right? There's no 100% AI. There's always going to be qualified, certified operators standing between our equipment and AI. And in the foreseeable future, AI is just to organize hundreds of thousands of input and output and deliver a data that you can rely on, and perhaps predict, an hour into the future, how the equipment is going to react, what the quality of water is going to be. And with those kind of data, again, like I said, make the operator more informed. Therefore, they can do better job to safeguard the water quality. So total autonomous, we don't know what that looked like.
Okay.
It depends on people's comfortable level, just like what you do at home. Right?
Or their imaginations, maybe.
Yeah. There are people who will push the limits, learn the lessons. All of us can benefit.
Yes.
Right. But if future is there for us to imagine and for us to create. To what degree autonomous.
That was a bar, John.
Yeah.
For us to imagine and create. I like that. So what you're basically saying is that we don't have to worry about like Skynet rising up and like taking our water away from us or like poisoning our water supply. That's not a thing, right?
No. We have, like I said, state certified operators standing between whatever AI we want to implement and to safeguard the water quality and the equipment they're operating. So, for the foreseeable future, there's no 100% automation planned. For example, I use the example of why the regulators provide 12 log removal. Why not 10? Right? Where this regulation comes from, right? So it based on professional recommendation, based on toxicologist, your doctor's input, right? So it go through a vetting process to come up with this regulation. So I think in the future of AI, there will be a regulation governing to what degree, in what industry that automation should be. And I think that provides a platform for all of us to participate in what regulation we should put on AI.
Proactively.
To what degree we feel comfortable.
Yeah. Civic engagement, folks. It's important.
That's
we have to be engaged.
It's all up to us.
It's up to us. In the meantime, it'll be our brave operators, keeping us between life as we know it now and the potential of a complete AI takeover. Who would have thought it wouldn't be Arnold Schwarzenegger? So we've kind of talked about how the operators interact with AI, and we now know that, this technology, machine learning, all of its bells and whistles, it's not here to replace the job of the operator. It's here to enhance what they're able to do and work more proactively. Can we talk about the data aspect of it, right? Because there's a lot of data being pulled. There's a cloud-based component. We're storing and moving that data through a cloud. Can you talk about any concerns that there may be with data privacy, or is this something that'll actually improve data privacy for us?
Yeah, not only data privacy, but security, right?
Yeah.
So what we implement here at Las Virgenes JPA is we call the air gap. That's a term from water industry. So air gap is where, when you flow water through air, it can't reverse the flow. Mm-hmm. There's a gap there. Mm-hmm. You're sucking air, but it will not sucking contaminated water from low gradient to high gradient. Mm-hmm. So we use that terminology for our safeguard our data transported through clouds. So it's a one-way connection. So we provide the data to AI through cloud. AI provide recommendation to us, but that recommendation doesn't directly go to our SCADA system, go to the computer,
right,
to activate whatever instruction. It goes to our operator, and our operator look at it based on professional knowledge, manually adjust the machines, treatment processes to make it more efficient. So in this case, even if the data is breached, even if the recommendation may not be optimum, you have a certified operator standing between. And that's the air gap.
Right.
That's the human gap to safeguard the data security.
Oh, I love that parallel.
Yeah.
Yeah, that was a good one, John.
So rest assured, we are using AI, like you said, as a tool to optimize the SCADA data that we have to be able to more efficient. But the machine is not directing how our operators or automate the adjustment process. So we still have a human aspect of that.
Right. And really, all in all, to kind of draw out and look at the big picture, I mean, we have been able to prove through this AI project with our demo that we can effectively use AI for optimization and for energy efficiency, the efficiency of the amount of chemicals that we use. All of this comes down to cost savings, right?
Absolutely.
All of this allows us to cut on operating costs, which eventually positively impacts our customers because that's saving them money. And so that's really the bottom line of how we're able to use AI here. I mean, this is all about efficiency and optimization. We have found in studies at Tapia, and indeed the Pure Water project at our demo that, there is still small gaps in areas that we can account for to help us save energy and help us, save on different operating costs. The chemicals involved with the Pure Water project, sodium hypochlorite, for example, very necessary for disinfection. There are oftentimes, as anything in the supply chain, there are shortages on this chemical that affect us. And we cannot afford, on behalf of our public and their health, to not have the materials that we need to make sure and guarantee that reliability. And so anytime we can cut back on the use to help us save it, we improve on that and thus improve upon our reliability. And so, again, we like to use our imaginations when it comes to AI and what it might do and what it can't do, but we have proven that it is effective and that it's worth investing in to supplement and enhance what we're able to do with the Pure Water project. And as you mentioned, optimizing energy efficiency and water quality. Those are our biggest takeaways.
Absolutely. So we're doing this, like you said, efficiency, but we're not sacrificing reliability and the quality that the service we provide. So that's very important, right? So AI make us more reliable, better quality, while saving energy.
Yes, more efficient. Efficiency always. So, John, you have given us some very common sense context and information about AI. I mean, just, how you mentioned we use AI at home all the time. I mean, I have an iPhone, sitting on my lap right now, and I don't think about how, like, that's AI, let alone, my Keurig or, my oven or my parents' fancy refrigerator. So, that's very helpful. We really appreciate you coming on. But before you leave, I wanted to do a fun little segment with you. Shout out to our interns, Ali and Alaya, who came up with this next segment that we are going to do with our guest, John, called Two Truths and a Lie. Are you familiar with this game, John?
No.
Good. Perfect. Okay, so I'm going to give you 3 statements that I did not provide beforehand, so he didn't have time to prep. I'm not going to make them too hard because this is our first time doing it, and you've been such an amazing guest. I don't want to throw you any curveballs or put you too much on the spot. But 2 of these statements are going to be truths, and 1 is going to be a lie. And you have to tell me which one is the lie.
Okay.
All right. So, statement number 1, in water, we can use AI to see into the future. You don't say it yet. Statement 2, AI may be used to create a brand new source of water. And statement 3, the implementation of AI could save ratepayers money in the future.
So which one is false, correct?
Which one is false?
So statement number 1 is false.
Why is that?
Because you can't use AI to see future in water. Is that what the question is?
Yes, yeah.
Yeah. But you can, using AI as part of the tool to create a new source of water.
That is correct.
Right?
Good job, John.
Thank you.
Thank you. That wraps up our segment, 2 Truths and a Lie. And that wraps up our episode. John, again, I want to thank you again for joining us. You gave some great information. Thank you for your willingness to chat all things pure water. And in our next episode, we are going to be getting into the specifics of CECs, or constituents of emerging concern. We'll see you again soon. Thanks, guys.
Thank you for listening to this episode of the Full Circle Podcast. Make sure to follow us on Twitter at LVMWD, on Instagram at Las Virgenes_MWD, and on Facebook at LVMWD. Find our Full Circle Podcast on your favorite streaming service, or go to ourpureh2o.com and smash on the Full Circle Podcast link for all other episodes. Thank you for listening to this episode of the Full Circle Podcast. Make sure to follow us on Twitter at LVMWD, on Instagram at Las Virgenes_MWD, and on Facebook at LVMWD. Find our Full Circle Podcast on your favorite streaming service, or go to ourpureh2o.com and smash on the Full Circle Podcast link for all other episodes.